going to send over a transmission media, right? So over the transmission media, the data is going to convert in the form of signals, right? So how it is going to convert the signals? What are the different methods that it uses to convert all these signals? So it has the different methods of converting the signals: digital to digital conversion, digital to analog conversion, analog to digital conversion, then digital that is analog to analog conversion. Once again, I am repeating, it consists of 4 methods of converting the data, that is computer data, into the signals. In the form of signals it has to convert. So it uses the 4 methods. So what are those 4 methods? The first one is digital to digital conversion, and the second one is analog to analog conversion, and the third one is digital to analog, and fourth one is analog to digital. So these are the 4 methods which it uses to convert your digital data in the form of signals. डिजिटल डेटा को डिजिटल सिग्नल्स में कन्वर्ट करना है, या तो डिजिटल डेटा को एनालॉग सिग्नल्स में कन्वर्ट करना है एंड देन ट्रांसमिटिंग ओवर द ट्रांसमिशन मीडिया, और एनालॉग सिग्नल को डिजिटल सिग्नल्स में कन्वर्ट करना है एंड देन सेंडिंग इट ओवर टू द ट्रांसमिशन मीडिया, और एनालॉग सिग्नल को एनालॉग सिग्नल्स में ही भेजना है, एनालॉग डेटा को एनालॉग सिग्नल्स में ही कन्वर्ट करके भेजना है. So these are the 4 methods that it uses for transmitting the data from source to the destination. So the first one we'll see about the digital to digital conversion, right? So we have understood the analog signals and we have understood the digital signals, right? So analog signals, it is in continuous format. Digital signals, it is in discrete nature. Analog signals will be in the form of sine waves, and digital signals, it is in the form of discrete, right? So you can see you can recall the diagram, right? So digital transmission, data or information, either it is stored in analog, as I said, or it is stored in the form of digital, right? So for a computer to use the data, it must be in that is discrete digital format. But computer में क्या होता है, सिर्फ डिजिटल सिग्नल्स में डेटा को स्टोर किया हुआ रहता है. दैट इज इट विल बी स्टोर्ड आइदर इन द फॉर्म ऑफ 0101010101. इस 0101 डेटा को क्या करना है, डिजिटल सिग्नल्स में कन्वर्ट करना है, सिग्नल्स में कन्वर्ट करना है एंड देन ट्रांसमिटिंग इट ओवर टू द ट्रांसमिशन मीडिया. और इस डिजिटल सिग्नल्स को हम लोगों को एनालॉग सिग्नल्स में कन्वर्ट करना है एंड देन ट्रांसमिटिंग इट ओवर टू द ट्रांसमिशन मीडिया. So similar to data, signals can also be analog and digital format. To transmit data digitally, it needs first to be converted, right? So as I said, there are 4 techniques we are using, and the first technique is digital to digital conversion. So what happens here, we'll see. As I said, डिजिटल डेटा को डिजिटल सिग्नल्स में कन्वर्ट करके फिर ट्रांसमिशन मीडिया में सिग्नल्स को भेज रहा है. फ्रॉम द सेंडर साइड, द डिजिटल डेटा इज कन्वर्टेड इनटू द डिजिटल फॉर्मेट and then those signals were sent over the transmission media, and this method we call it as a digital to digital conversion. I hope the heading is clear now, right? So digital data को डिजिटल सिग्नल में कन्वर्ट करना है, कन्वर्ट करके फिर उस सिग्नल्स को ट्रांसमिशन मीडिया में भेजना है, राइट? सो एंड टू डू दिस इट यूजेस द following method, that is line coding and block coding. You can see here the highlighted point. डिजिटल टू डिजिटल को कन्वर्ट करने के लिए it uses the line coding and block coding. And again we have the different types of line coding. पहले line coding क्या है वो हम लोग समझ लेंगे. Right, so what is line coding? Let's see the figure. Can you see the screen?
Yes, ma'am.
Okay, fine. This is the process of line coding. Digital to digital conversion uses two techniques. One is line coding and second one is block coding. So what is this line coding? The line coding is nothing but what? The process of converting digital data to digital signal. The process of converting the digital data to digital signal is said to be line coding. How it converts? This is a sender PC and this is a receiver PC, right? So sender PC, right? So you know that the computer stores whatever the data we are typing, whatever the information we are typing, everything it is converted in the form of 0101010101, and that data we call it as a digital data. Now your digital data is ready. As soon as when you click on the send button, right, if it is using the line coding technique, right, if it is using the line coding technique, then an encoder will be there. It is going to convert. This is an encoder. This encoder is going to convert your digital data into the digital signal. You can see here the format of the digital signal here. It is going to convert in the digital signals, and these signals were sent over the transmission media. These signals were sent over the transmission media, right? So when it reaches to the receiver side, right, so it all these digital signals will transmit over a transmission media wherever the destination address lies. And suppose here the destination address is there, the receiver PC is there here, and at the receiver PC we need a डिजिटल सिग्नल्स को क्या करना है, वापस डिजिटल डेटा को कन्वर्ट करना है, क्योंकि कंप्यूटर सिग्नल्स को अंडरस्टैंड नहीं करता है. कंप्यूटर क्या अंडरस्टैंड करता है, ओनली डिजिटल डेटा को अंडरस्टैंड करता है. सो व्हाट इट विल डू, so these digital signals were converted. It means it is decoded by the decoder. A decoder will be used at the receiver PC, which is going to decode the digital signals, and again it will convert back to the digital data, and these digital data were sent over the receiver's PC. It means the same digital data receiver को reach हो रहा है, and the receiver is able to, whenever he clicks on the open, suppose आप लोग एक mail open कर रहे हो, so when you click on the any inbox, any mail, right, so what it will do, it will show exactly the data what the sender has sent. So this process we call it as a line coding method, right? So digital data को digital signals में convert करना है. For that reason it uses the encoder, and at the receiver PC it uses the decoder in order to reconvert back to the digital signals to the digital data, and these digital data were sent over to the receiver's PC, and receiver is able to read the data as it is, whatever the sender has sent. This is a process of your line coding. Yes, I hope you have understood. Okay. Next, now this line coding process again consists of the following different methods. The line coding process consists of the following different methods. So digital signal is denoted by discrete signal, which represents the digital data, there are three types of line coding schemes. So what are those types? Unipolar, polar, and bipolar. Apart from these three, again there are two more types are there, that is multi-level and multi-transition, right? So again there are total, you can say, five types are there, but three main important types I am taking, that is under line coding you have three types: unipolar, polar, and bipolar, right? Simultaneously you can make a note of all these. You keep a pen and paper with you, you make a separate notebook for your computer network, so whatever the concept we are teaching, right, so you can make a note in that, right, so you'll understand whatever what we are covering, right? So as I said, line coding is basically five types: unipolar, polar, and bipolar. Apart from these three, it is multi-level and multi-transition. So these are the again two types. So total five. So we'll see the first one, that is unipolar. So what is unipolar? Right, so basic concept about the line coding is what this we are learning under the digital to digital conversion, right? So you know that now digital data को digital signal में convert करना है और उसके बाद that signals को transmission media में भेजना है. So this is a basic fundamental concept about the digital to digital under that line coding. So now line coding also explains the same thing, but with diagrammatically we have understood. Next, the unipolar. So here exactly we'll take one example and then we will try to represent about the unipolar, right? So what is the unipolar? Unipolar encoding scheme uses the voltage levels to represent data. It means in this case to represent binary 1, that is high voltage को represent करने के लिए binary 1 use करता है, and to represent 0, it means no voltage is transmitted. 1 means the high voltage is transmitted across the transmission media. If it encounters 0, then there is no voltage. That is, no voltage is transmitted. This is the basic definition about your unipolar, right? So unipolar में क्या हो रहा है? Once again I am repeating. To represent binary 1, बाइनरी 1 को रिप्रेजेंट करने के लिए हाई, इट मींस हाई वोल्टेज इज ट्रांसमिटेड, एंड टू रिप्रेजेंट 0, that it means that no voltage is transmitted. So we'll take one example. So it is also called unipolar non-return 0. Unipolar non-return 0. That is N. Take small one. NRZ. This unipolar transmission can also be called as non-return 0. That is NRZ, because there is no rest condition. That is, it either represents 1 or 0. It either represents 1 or 0. So these two you try to remember. So when we study the next example, next types, then you will understand why we are specifying it either represents 1 or 0. 1 means an voltage, high voltage is transmitted, and 0 means no voltage is transmitted. Suppose for example this is your data 0 1 0 1 0 1 1. If this is your data, then so here when it is 0, then no voltage is transmitted. It means there is no voltage, it remains on the same state, there is no voltage. And if it is 1, now it is in this example it is 1, then there is a high voltage is transmitted. So this, it represents the 1, right? So again there is no voltage, that is 0, it is 0, right? So again we have 1 means a high voltage is transmitted. High voltage is transmitted. Right, again 0, no voltage is transmitted. Again 1 it is, then high voltage is transmitted up to here. If it is a 0, it will come down. Now in this case it is not 0, then it is 1. 1 means what it will do? In the same state again a high voltage is transmitted, right? So this is the complete high voltage, it is transmitted, and this process it continues. This process it continues. Simple thing. It is 1 means high voltage and 0 means no voltage, right? So this is your simple diagram about your unipolar non-return zero, NRZ, and it is with respect to time and amplitude. Is that clear? Yes. If the diagram is, if you understood the diagram, then you can type in the chat box diagram. Because in each and every application, that is each and every example, a very slight variation is there. A slight variation is there, so that you need to understand. Okay, fine. So next, this is about your unipolar, right? So next is second one is which one? Polar encoding. So we have unipolar में एक type है, that is non-return zero. Next polar, second type is polar. So here in polar encoding scheme, it uses multiple voltage levels. This is very important, right? So it uses multiple voltage levels to represent binary values. So polar encoding is available in the following types, that is polar non-return zero, polar NRZ, polar NRZ, and again polar NRZ, it uses two different voltage levels to represent the binary values. It uses two different voltage levels. So here it uses two different voltage levels to represent binary values. Usually positive voltage represent 1. Try to focus here. Positive voltage represents 1. Negative voltage is represented by 0. प्रीवियस केस में क्या हुआ था? 0 को लो वोल्टेज करके कंसिडर किया था, राइट? इधर पोलर नॉन रिटर्न 0 में क्या हो रहा है? इट यूजेस टू डिफरेंट वोल्टेज लेवल्स टू रिप्रेजेंट द बाइनरी वैल्यूज, राइट? सो पॉजिटिव वोल्टेज को 1 करके रिप्रेजेंट कर रहा है और नेगेटिव वोल्टेज को 0 करके रिप्रेजेंट कर रहा है. सो इट ऑल्सो, that is NRZ, because there is no rest condition, right? Here there is no rest condition because 0 also we are considering it as a negative value, and that takes the discrete format. That signal also transmits. And NRZ again has the two types. NRZ is having the two types. What are those two types? NRZ-L and NRZ-I. We'll see with the help of example. Suppose if your binary pattern is 0, 1, 0, 1, 0, 1, 1, 0, 0, 1. If this is your binary pattern, okay. So if this is your binary pattern, right? So with the help of NRZL, so what the polar uses, it uses the two voltage levels, that is 1 to indicate the positive and 0 to indicate the negative. Initially it is 0. You can see here in this pattern 0 1 0 1 0 1 1 0 0 1. Initially it is 0, means negative. Here upper side you can consider it as a positive, and below you can consider it as a negative. Okay, so if it is 0 then negative, so it will somewhere, and it is with respect to the amplitude. This is with respect to amplitude, and this is also downside, also we can consider it as an amplitude, and with respect to time. It will start from here because it is negative value. Somewhere it will start from here and it traverses and it reaches here, and it finds the 1, means high voltage will be represented by 1. Again the low voltage, it comes down, means the signal is traversing down. Again 0 voltage, again it represents, then again 1, it goes up and traverses, and 0 it comes down, that is negative voltage, right? Again 0 it traverses, again 1 it goes up, and here this is the voltage level 1 is transmitted up to here. Next also 1 is there, again it remains high, positive only, and again it is 0. You can see here 0, it traverses down, then again we have 0. 0 means it will be in the same state, traverses in the negative side, and again we have 1, and this it is, it continues. If the data is there, so again it continues in this format, right? So this is polar non-return 0 L format, it is L format. So L format में क्या होता है? It is as good as we are telling that polar non-return 0, right? I format में क्या होता है? We'll see, right? So L format में क्या हो रहा है? That is positive and negative voltage. Positive voltage, that is high voltage, and low voltage. High voltage is represented by 1 and low voltage is represented by 0. Is that clear? Yes. Now you can compare the down part, and can anyone able to tell what is happening in the NRZI part? Can anyone tell what is happening in the NRZI format? If you understood the above diagram, so how do you interpret with the below diagram? How do you interpret? Yes. So let me ask Adarsh. Adarsh, unmute your audio video and tell me, how do you interpret the second diagram?
Ma'am, no, does not know.
You don't know, it
Second,
does not.
it
हाँ,
हाई लेवल मैम समझ में नहीं आ रहा सेकंड वाला उसमें वन
सेकंड वाला
वन में भी
बहुत कंफ्यूजिंग.
नेगेटिव है वन में भी
हाँ तो
नेगेटिव है
हाँ तो बहुत कंफ्यूजन हो रहा है. सो राइट, 0 तो बराबर दिख रहा है, लेकिन 1 में क्या हो रहा है और 0 में क्या हो रहा है समझ में नहीं आ रहा है. 0 है तो नीचे आना चाहिए, करेक्ट?
यस
लेकिन ऐसा नहीं हो रहा है, right? So again we have to go according to the definition. Can any other person can interpret this diagram? Next कौन है ये? आरती. आरती, unmute yourself, audio video.
Ma'am, I don't know.
Okay, so have you understood till now whatever we have done?
Yes, ma'am. Upper diagram.
Show me your face. Show me your face. Okay, so tell me. I not understood me. Okay, इससे पहले जो अभी जो दो डायग्राम बताया था उसको समझ में आया?
Yes, ma'am.
Okay, fine. Can any person interpret this diagram? Hmm? No one. Yes? तो मुझे ही बताना पड़ेगा. No one. Okay, fine. So how do you interpret the second diagram? पहले डायग्राम तो पॉजिटिव और नेगेटिव तो बराबर आ रहा था. अभी पॉजिटिव नेगेटिव किधर जा रहा है क्या पता. Okay, so first try to understand the definition. If this is your bit pattern, same pattern हम लोग लिया है ताकि हम लोग differentiate कर सके first और second figure में NRZL और NRZI. Here NRZL changes voltage level when a different bit is encountered. That is NRZI changes voltage when one is encountered. अभी समझ में आ जाएगा ये डायग्राम. NRZI में क्या, that is NRZI changes voltage level when one is encountered. अगर 1 दिख रहा है तो वोल्टेज लेवल को चेंज करेगा. राइट. NRZL में क्या हो रहा था, पॉजिटिव और नेगेटिव बराबर ले रहा था. सो सपोज दिस इज यूर 0, इट इज नॉट गोइंग टू चेंज. राइट. यस, 0 है तो नेगेटिव वैल्यू से स्टार्ट तो हो रहा है, लेकिन चेंज कभी होगा 1 अगर एनकाउंटर है तो. 1 इधर है बराबर, तो यहां तक आके चेंज हो गया. बाद में क्या है, 0 है तो वोल्टेज लेवल चेंज नहीं होगा. चेंज कभी होगा, व्हेन इट इज 1. अभी नेक्स्ट क्या है, 1 है तो क्या हो रहा है, वोल्टेज लेवल चेंज हो रहा है. वोल्टेज लेवल चेंज हो रहा है. नेक्स्ट क्या हो रहा है, 0 है तो 0 है तो क्या हो रहा है, वोल्टेज को चेंज नहीं हो रहा है. राइट. नेक्स्ट क्या हो रहा है, सो 1. राइट. सो हियर इट इज 0 यहाँ तक आ गया, फिर 1 इट हैज चेंज्ड. अगेन इट इज 1, अगेन इट इज चेंज्ड. बाद में क्या है, 0 है. 0 मतलब नो चेंज, 0 मतलब नो चेंज. और बाद में क्या है, 1 है मतलब इट हैज चेंज्ड. दैट इज व्हाई the difference lies between the first diagram and the second diagram. किधर 1 है उधर वोल्टेज चेंज हो रहा है, और 0 आए तो वोल्टेज चेंज नहीं होगा. दैट इज द डिफरेंस बिटवीन NRZL and NRZI. That is why the diagram looks, you can see here, you can see the difference here between the first diagram and second diagram. Yes, so you can see the difference between the first diagram and second diagram. So now if you have any doubt you can ask here. I hope now the time is also complete. Yes, so still if you have any doubt in the second diagram and the first diagram, you can ask. No doubt? Yes? No doubt. Okay. People are responding. Fine. So it means you understood. Okay. Understood? No. Okay. So you understood. So let me stop here. If you have any queries,